Hello and welcome to Spur Economics. Today, we'll be discussing the information criteria such as Akaike's and Schwarz information criteria that are often used for model selection. Please like, share and subscribe if you like our content. Visit the Spur Economics website for more knowledge on econometrics, link is in the description. Information criteria are used to compare and choose among different models with the same dependent variable. Akaike Information Criterion or AIC and Schwarz or Bayesian Information Criterion, often called SIC or BIC, are most commonly used for model selection. These information criteria overcome the drawbacks associated with R-square-based measures. For instance, the value of the R-square can be increased by including more independent variables in a model, even when the variables are unnecessary. However, AIC and SIC impose a penalty for including unnecessary independent variables. Moreover, the penalty is relatively harsh as compared to adjusted R-square. This means that information criteria are often better in terms of determining the fit of a model and deciding which variables may be unnecessary. That is, information criteria can be used to determine and drop unnecessary independent variables. Moreover, the traditional R-square and adjusted R-square should be used only for in-sample goodness of fit. They generally do not perform well in the case of out-of-sample observations. For out-of-sample forecasting and goodness of fit, these measures are not reliable. Information criteria such as AIC and SIC or BIC, on the other hand, perform better for out-of-sample goodness of fit. The equations shown here are the general formulas for estimating the Akaike and Schwarz information criteria. These formulas are sometimes slightly adjusted based on the model. For example, suppose we are using information criteria to decide lag length of VAR models. Then, we have to slightly adjust these general formulas to incorporate multi-equation or multivariate structure of VAR models. However, the general logic stays the same. Here, RSS is the residual sum of squares, n is the total number of observations, and k is the number of parameters including the intercept. If we look at the AIC formula, 2k divided by n represents the penalty for including additional independent variables in the model. This value will increase as k increases. If the additional variable is unnecessary, it will not decrease the RSS and the overall value of AIC will increase due to the penalty. Hence, we should choose the model with the minimum value of AIC. Similarly, k by n multiplied by log n in SIC represents the penalty for additional independent variables. The value of SIC will increase if the additional variable is unnecessary or unimportant because k will increase. Hence, we also choose the model with the minimum value of SIC. It is important to note here that the dependent variables should stay the same when comparing models. We can only compare and choose among the models with different independent variables. In ARIMA, ARIMA and ARIMA models, one of the most important steps in estimation is to choose the appropriate number of autoregressive and moving average terms. Information criteria such as AIC and SIC can be used to choose the number of MA, seasonal MA, AR, or seasonal AR lags to include in a model. First, we must estimate each ARIMA or ARIMA model and the information criteria for each model. After comparing the information criteria, we choose the model with the lowest value of AIC or SIC. The table shown here compares AIC and SIC for 4 different specifications of ARIMA model. Based on the results, ARIMA 111 seems appropriate because AIC and SIC are minimum for this model. In practice, however, we should estimate and check many more different specifications. It is important to note that choosing AR or MA terms using information criteria is not a foolproof system. For example, a model chosen by information criteria may still exhibit residual autocorrelation, in which case we may have to adjust the number of AR and MA terms. In the vector autoregressive or VAR model, all variables are considered endogenous variables. The number of equations in VAR is equal to the number of variables. The independent variables include the lags of all the variables in the model. However, it is not possible to know the appropriate number of lags beforehand. Therefore, we must determine the order of the VAR model or the number of lags that must be used in VAR. For this purpose, we use information criteria. It is important to note that the general formulas for AIC and SIC mentioned earlier have to be slightly adjusted for multivariate models such as the VAR and VECM models. To learn more, see the links in the description. Therefore, we must estimate VAR models with different lag lengths and calculate the information criteria for each model. After comparing, we choose the lag length that has the minimum value of information criteria. In the table shown here, we have the values of AIC, SIC and HQIC for VAR models with different lag lengths. AIC indicates 3 lags, whereas SIC and HQIC indicate using 2 lags in the VAR model. Here, we should prefer 2 lags in VAR or VAR2 model. This is because AIC has been observed to overestimate the lag lengths for multivariate models such as VAR and VECM. On the other hand, SIC and HQIC perform more consistently. As a result, we prefer SIC and HQIC for multivariate models such as VAR instead of AIC. If you found this video helpful, don't forget to like, share, and subscribe to our channel for more in-depth discussions on econometrics topics. Leave your questions and comments below. See you next time.